In this video, I am going to explain kinematic synthesis. Three distinct types of kinematic synthesis methods used in mechanical engineering to design mechanism. Why I inform mechanical engineering? Most of the machines are designed by mechanical engineering. If you go for electronics, electron circuits, they are going to design ECM, circuit boards, and for a civil engineering, the civil structures they are going to design. Okay, but most of the structures for machine structures are designed by mechanical engineering. Type synthesis. This method involves the determination of the type of mechanism that can generate a desired motion. So the desired motion, which motion we want, that we want to decide in the type synthesis. Number synthesis. This method involves the determination of the specific number of links and joints required to generate a desired motion. For obtaining the desired motion, how many number of links are required and how many number of joints are required, that you can decide. That is known as a number synthesis. Dimensional synthesis. This method involves the determination of the specific dimensions of the mechanisms, components that will generate the desired motion. You can see that for getting the desired motion, type synthesis, number synthesis, dimensional synthesis. Type synthesis will gives the what type of mechanism you want to generate. Number synthesis, how many number of links and joints you want for getting the desired motion. Dimension synthesis, the dimensions of the specific the links, those we want to find out using the dimensional synthesis. So overall, the synthesis means these are the three basic types: type synthesis, number synthesis, dimensional synthesis. Position synthesis of a linkage is the determination of the proportions of the links necessary to accomplish desired motions. So we want certain desired motions. For the desired motions, what is the linkages are required, that is gives in this position synthesis. So there is a two position synthesis. One is rocker output and second one is a coupler output. The rocker output, the pure rotation, coupler output, complex motion. It's not complete rotation, is a combination of the oscillation and the translation. That's called complex motion. So the Grashof equation is a mathematical relationship used in the design and analysis of 4-bar linkages. It relates the lengths of the links in a 4-bar linkage to the maximum and minimum crank angles at which the mechanism can operate. The Grashof equation is given by S plus L less than or equal to P plus Q, where S is equal to the shortest link length, L is equal to longest link length, P and Q is equal to other two remaining link lengths. So the equation is used to determine whether a 4-bar linkage is Grashof or non-Grashof. So based on this equation, we are going to determine whether it is satisfied the Grashof or not satisfied. A Grashof linkage is one in which the sum of the shortest and longest link lengths is less than or equal to the sum of the other two link lengths. If this condition is satisfied, then the linkage can rotate through a complete cycle without any of the links crossing each other. So overlapping, crossing is not happening once it satisfies this equation. If not satisfied, all these problems may arise. That's why before going to the design, the link lengths, we want to verify whether the Grashof equation is satisfied or not. If the Grashof condition is not satisfied, then the linkage is non-Grashof. In this case, the linkage can only rotate through a limited range of motion and the mechanism may experience singular positions where it cannot move. The Grashof equation is an important tool in the design of linkages for various mechanical systems such as engines, robots, and machines. It helps ensure that the mechanism will operate smoothly and without interference between its links. Design a 4-bar Grashof crank rocker to give 45 degrees of rocker rotation with equal time forward and back from a constant speed motor input. This is the problem is given. We want to design the mechanism, suitable mechanism to obtain the equal time forward and backward motion. Okay, here design a 4-bar Grashof crank rocker to give 45 degrees of rocker rotation. So that means here crank means it's having the complete rotation, that is input is given to the crank. Rocker is output lever that will oscillate through a range of 45 degrees angle. Okay, so this is the input is given. So with this input we want to design a mechanism. Now I want to explain stepwise procedure how we are going to design a mechanism for the given problem. Now let us take convenient point, take the convenient point, then that assign O4, then take the rocker arm, okay, the rocker arm, draw the one certain position that is not given, you take any position, okay, that's B1, okay, now I take in O4 and B1, O4, B1 is the rocker link, okay. So now it's not mentioned we take any angle, but from this O4 B1, but here condition is given 45 degrees of rocker rotation. Now you can take O4 B1 as a reference. From that you can take 45 degrees angle and draw the another position of this rocker link. Okay, that is assigned as a B2. Okay, now you can see that O4 B1 is one position and O4 B2 is the another position. These are the two extreme positions. So the rocker can oscillate about O4 from O4 B2 to O4 B1. So that is a 45 degrees angle that is given in the problem. Now we want to decide where we want to keep the center of the crank. For that what we can do is from the B1 and B2 draw the line passing through these 2 points B1 and B2 and extend that line. Now let us see that I constructed one line. It is passing through B1 and B2 and extended up to certain length. The length is not known. Okay, you take any length and you can extend. Now bisect B1 B2. The B1 B2 can bisect. Now take compass and keep B1 as a center. Take radius is more than half and draw the two arcs. Let us see that here there is a two arcs. Now similarly same radius, keep B2 as a center and draw the two arcs that will intersect these two. Now draw the line passing through intersection of these arcs 2 points. Now these two intersection points are there. Now draw the line passing through these 2 points. Now this blue line is bisecting this B1 and B2. Okay, now the intersection of B1 B2 with blue line is mark the point. That point is let us assign O. Okay, now you take any convenient point on the extended line, a convenient point on the extended line. That point is the center of the crank. That point is the center of the crank. Now assign O2. Now we take B2O or OB1 as a radius and O2 as a center. Draw the circle. O2 as a center and draw the circle. Okay. So that is a O2A1 is equal to the B2O or OB1. Now draw the circle. The O2A1 take as a radius and draw the circle. Okay. Now the circle is obtained. Now A1 is one extreme position and you can see from join A1 to B1, that is the one link. Okay, A1 to B1, that is the one link. That link is called as a coupler link. Now see the another extreme position from A1 to other end of the circle, mark the point. that is assigned as a point A2. Now from A2 to B2 is the another position. A2 to B2 is the another position. Okay, now join O2 and O4 that act as a fixed link. O2, O4 act as a fixed link, and O2, A1 or O2, A2 that is act as a crank. Then A1, B1 that is a coupler, or A2, B2 is a coupler. Then O4, B1 is a rocker. Okay. Now you can see that in this mechanism, the crank, let us initial position of the crank is, let us assuming O2 to A1, and this O2 to A1 is rotating in clockwise direction, then A1 is reaching to A2, so the angle covered by the crank is how much? 180 degrees. So during this rotation, so what happens? The coupler is moving B1 to B2. And again from A to A1, the coupler is moving from B2 to B1. Okay, so that is a forward and backward motions. Here, crank covered by the angle of each stroke is same. That means equal time take place in both the directions. If the angle is different, then the forward and the backward motions are different. That's here in the problem is asked, you design the mechanism in such a way that it will take the forward and backward at the same time. That means angle covered by the crank in both the strokes are same. That is happened here. So the O2, A1, A2. Okay, see that A1, A2 diagonal opposite. So that angle covered for a forward stroke and backward strokes are equal to 180 degrees. So you can obtain equal time. Okay, so this is the required synthesis of the mechanism. So that's now we design the mechanism. Now it act O2, O4 act as a fixed link, O2, A2 is a crank, and A1, B1 is a coupler, and O4, B1 is a rocker. I hope understand this problem, how we are going to design the 4-bar mechanism for this given condition. Let us move to the next problem. So this is for the same what construction is happening, that in terms of the linkages are looks like this same problem. Okay, that O2 and O4 is fixed links, and O2 this the link 2 is a crank. It's rotating about the pivot point O2, and the crank is connected to the coupler link at point A1. Okay. Now that is a link 3. You can see that B2 is moving to B1. Okay, that is the angle covered by O4 B2 to O4 B1 is 45 degrees. Okay. So that is the mechanism we designed. Now let us see the second problem. Design a 4-bar linkage to move the link CD shown from position C1 D1 to C2 D2 with moving pivots at C and D. Moving pivots at C and D. Here this problem is given. Design a 4-bar linkage to move the link CD shown from the position. The link CD is given two positions. C1 D1 is the one position. Let us see that this is the one position, and the second position is given C2 D2. Okay, now it has assigned the points C1 D1 and C2 D2. These are the two positions are given. Now you can for moving C1 D1 to C2 D2, now we can design the mechanism. That is our task. We want to design. So output here, the link CD here to move from C1 D1 to C2 D2. Now we can design a mechanism. In that, what we can do is first locate the center of rotation of this point C1 D1 and C2 D2. So these links, how it will move. That is happening. First you have to the C1 point. Let us consider the C1 point. C1 point is moving from C1 to C2. How it is happening? There is a two chances. One is the linear way it will move C1 to C2, and as second one is in circular fashion. Now you can see it, circular C1 C2 is also happening. Similarly for a D1 D2 also the linear movement D1 to D2, and circular it will move D1 to D2. Okay. Now what we can do is first we have to take bisect of C1 C2, draw the one line, Okay, draw the one line for bisect line. Okay, for that we have to draw the two arcs like in the previous problem. What I explained how we are going to construct bisection line. Take more than half of the radius and take C2 as the center and draw the arcs on either side. Now take C1 as the center and same radius, draw the arcs. The intersection points are obtained. Through intersection points, draw the line. This line will bisect the C1 C2 and this line should be perpendicular to C1 C2 and it passes through the midpoint. Now similarly construct for D1 D2 also. Now draw the arcs on either side. Now draw the line passing through these points. Okay, now see that these two lines will intersect. That intersection point is marked as a center. Okay, now this is the center O1. So about the center, the link C1 D1 is having the pure rotation to reach the new position C2 D2. Okay. Now we can join O1 to C1 with a link. Okay. Next O1 to C2 is the another link. Okay. Now this is initial position is O1 C1 D1 and final position is O1 C2 D2. Okay. Now take any convenient point on the links O1 C1 and O1 C2. Let us I have taken this convenient point B1 and on O1 C2 the B2. Okay. Now draw the line which is passing through these 2 points. Draw certain length like in earlier problem how it constructed. Similar way you can construct here. Draw the line B1 B2 and extend. Okay. Now on this line you can take the convenient point, that is the center of the crank. Now you can draw the radius crank. Okay, the crank radius how much you want to take, that you can take bisect B1 B2. Now you can see that that line itself is bisect the B1 B2. That the point intersection point you can mark, that is a just mark the point assigned to O. Now here B1O or OB2, these two are the take as a radius and O2 as a center, draw the circle. Okay. Now you can see that O2A2 that is equal to B1O or OB2. Now draw the circle which is take center O2 and O2A2 as a radius, draw the circle. This is acting as a crank. Okay. Now other end also you can mark the point A1. Okay. Now join A2 to B2 is one position and A1 to B1 is another position. Okay. Then join O1 O2 as a fixed link. Okay. So now somewhat it is similar to the previous problem. Okay. So now we can see that the extreme positions A1, okay, that A1 extreme position, in that case here the link is O1 B1 C1 D1 position. If the crank is at A2 position and this is in the O1 B2 C2 D2 position, these are the two extreme positions. Okay. The crank is moving from A1 to A2. Crank is moving from A1 to A2. Then the link is pivoted at O1 and this bell crank lever O1 B1 C1 D1 is moving forward direction and it reaches to the another extreme position. It reaches to the another extreme position. Okay. So now here O1 O2 act as a fixed link. O2 A2 act as a crank, that is a link number 2, and A2 B2 or A1 B1 is a coupler, that is link number 3, and O1 C1 D1 or O1 C2 D2 are rocker, that is a link number 4. These are 4 links are used to construct this mechanism. So now this is the required design of the 4-bar linkage to move the link CD from C1 D1 to C2 D2. Okay, I hope understand this problem. So this is the real the linkages of the problem. That earlier is how we constructed. Now this is the real. Okay. Now you see this bell crank. The bell crank is moving from initial position to the final position. That angle is given 45 degrees. Okay. Okay, now coming to the next problem, that is a 3-position synthesis of a 4-bar mechanism. 3-position synthesis of a 4-bar mechanism, that inversion method. Now let us take one convenient point and assign A draw the another convenient point S and D, draw the line. Now this AD is acting as a fixed point or fixed link. AD is acting as a fixed link. Now take A as a center and take the suitable dimension of the crank length and take A as a center and draw the radius. Okay. Now we want to show the three positions of the crank. And now you can see that the first position, that B1, that is AB1 at an angle theta 1 from the reference line. Here the reference line I chosen is a horizontal line. From horizontal line, this is theta 1. Okay. Now you can see the another position, that is at 90 degrees B2. Okay. So that is with reference to the previous position, its angle theta 2. That is means AB1 to AB2 is the angle theta 2. Now in the third position, that is B3, that is an angle theta 3 from the second position. Okay, now you can see that it's representing theta 1, theta 2, theta 3. The three positions B1, B2, B3. Okay, now three positions are known. From this we want to construct the mechanism. First what we can do is, so now the D is the center of that another fixed point. From D join B2 and B3. Okay. Now you can join from D B3 and B2. Okay. Now take D B3 as a radius and D as a center and draw the circle. See that I drawn the circle. The D as a center, D B3 is radius, draw the circle. Now similarly take D as a center and D B2 as a radius and draw the another circle. So now I drawn another circle. Okay. Now on this circle, these are the circles or locus of these points B2, B3. These are the locus of these points. Okay. Now we can take a reference of you can see that the crank is moving from AB1 to AB2 through an angle theta 2. Okay. AB1 to AB2 through angle theta 2. Now we take angle from DB2, from DB2 line in clockwise direction through angle theta 2, draw an angle and draw the line. Okay, now I have drawn this line by taking this angle theta 2. Okay, from the line DB2. Now this line intersecting the circle which is passing through B2, that mark as a center. Okay, now that is assigned a point. B2 is moving from B2 to B2 prime. Okay, B2 to B2 prime. Now similarly, the B3 is moving on the outer circle. So now, from AB2 to AB3, it covers the angle theta 3. So that means from DB2 prime, take angle theta 3 and draw the another line. Okay, now this line I drawn, so that okay, that angle is that this line is intersecting the outer circle. Okay, and this angle is theta 3. Now that intersection point is a B3 prime. Okay. Now join B1, B2 prime, B2 prime to B3 prime with a lines. Now you can see that we are joined B1, B2 prime, B2 prime to B2 prime. Now I want to draw the bisection. In the earlier problem, how you are bisect the line, same you can use here also. B1, B2 prime, draw the bisector line. Okay. Now this line is passing through midpoint and perpendicular to B1, B2 prime. Now similarly draw the another line which is perpendicular to B2 prime to B3 prime and passing through midpoint of that link. Okay. Now these two lines are intersecting. That intersection point mark as a C. Intersection point mark as a C. Now join B1C. Join B1C. This is the one link. And join C and D. This is the another link. Okay. Now complete the 4 bars here. AD is acting as a fixed link and AB1 acting as a crank, B1C acting as a coupler and CD acting as a rocker. Okay. Now this is the 4-bar mechanism. AB1CD is the 4-bar mechanism. Okay. So we are going to, so after construction, we are going to measure the distances of B1C and CD. Okay. Initially, we are assuming AD and AB1. Okay, we are assuming AD, AB1, and we taken the three portions of the crank. And with this given data, we are constructed a 4-bar mechanism. Okay. So likewise, there is several approaches are used to construct the 4-bar mechanism. I hope these problems will understand. In the similar way, we are going to solve the problems.